Today we're going to pick up with more reflections. Instead of going over the x-axis or the y-axis, we're going to reflect through a different line or possibly a point. Here's the note packet that you'll need for today's lesson. There should be 4 pages. Let's start with a reflection in the line y equals x. This line we've seen before, and since the values of x and y are equal, we know that if x is 0, y is 0. If x is 3, y is 3. So what you're getting is this diagonal line, 1, 1, 2, 2, 3, 3, and so on. But it will always pass through the origin, and it's always going to have this positive slope. If we want to abbreviate, we'll use lowercase r for reflection, and then in subscript, we're going to put down the line of reflection. So in this case, y equals x. Recall this is the notation that we use to abbreviate the process. We're going to reflect triangle ABC in the line y equals x to create triangle A prime, B prime, C prime. If you look at the location of B at -3, -1, and then its new location at B prime, -1, -3. Let's look at A, -4, 2, and A prime, 2, -4. It appears as though we're just switching the location of x and y. So with this specific line, y equals x, we do have a rule. So we have generically point P located at x, y. It will map itself to P prime by switching the location of x and y. So this rule will always hold true for the line y equals x. If you prefer to count on a diagonal just like the line is lying. So B is diagonally 1 block to the line of reflection, and B prime is 1 block away. So just make sure you count diagonally to locate the correct location. For example, number 1, we have triangle HMO. It does say that the use of the grid is optional. That means if you know the rule, you don't have to graph it. You can go ahead and just complete the full mapping, and that would be enough work. But for today's lesson, I am going to go ahead and graph. So I'm going to start by plotting triangle HMO. And remember, all vertices should be labeled, but to keep the presentation clean, I'm just going to skip that part. I'm also going to plot the line y equals x. I would encourage you to plot this in a nice bright color so that it stands out. Red, pink, orange, and then your eye will be drawn to that. All right, if I apply the rule y equals x, I know that the location of x and y will change. So I have listed my prime locations. And now that I know where they are, I'm going to go ahead and plot those in the grid. And remember, we said yesterday, if your original figure lies across your line of reflection, your image will as well, and the two figures will crisscross. We do have the same shape, and it is the same size with this reflection, and that was a property we also discussed yesterday. In example 2, we have triangle HMO, but now we're being asked to reflect in the line y equals -x. This is not a rule that we developed. In fact, quite often, the line of reflection will not be something that has a rule. So I'm going to go ahead and plot that. So x is -1, y is +1. X is -2, y is 2. Basically, this has an intercept of 0 and a slope of -1. Now I'm going to go ahead and plot my triangle HMO. And because I don't have a specific rule, the best thing I can do is count. So if I start here at -3, 1, I have to diagonally go 1 block to the line of reflection and then 1 away. So let me just mark this. So I'm going to be located right here. The point here at 0, 4 has to go 1, 2 on a diagonal to get to the line. So 1, 2 away. This is its location right here. And this point at 2, 0, 1 block on a diagonal, 1 away. So there's the new image. They're actually overlapping quite significantly up here at the top. You can see that. And since I didn't have a rule, I'm going to go ahead and just pull my points right from the diagram. So there's the rule of a reflection in the line y equals negative x, and the location of all my prime pieces. Now, just like that last example, the line of reflection can be any line in the coordinate plane. So in this example, this is a vertical line, so it's got a special equation. It's crossing the x-axis, so it'll be x equals, and the point that it crosses is at -2. So the equation is x equals -2. So there's the abbreviation, lowercase r, in subscript, the line of reflection. Now, when the line of reflection is anywhere in the coordinate plane besides the axis or y equals x, we typically do not have a rule. So I'm going to highly encourage you to draw the line of reflection, and then you're just going to count, and that's the method that we're going to use. So B, this line is vertical, so I'm actually counting horizontally 1 block to it and 1 block away. In example number 3, we have triangle JKL, and we're reflecting in the line x equals -1. So I'm going to go ahead and put x equals -1 there, and I'm going to plot my triangle. Notice the figure isn't overlapping, but it does have a point on the line. So when I go to graph my image, this point will continue to stay there. Remember, this is an invariant point or fixed point. So we're going to count at the top, 1, 2, 3, 1, 2, 3 away. So I'm going to have a point right here. And for this point on the left, 1, 2, 3, 4, 1, 2, 3, 4. And then I know I have one down here. So there's my reflection. And same thing here, because there was no specific rule, I'm going to go ahead and just use my graph to produce my points. So we reflected in x equals -1, and we have j prime, k prime, and l prime. And l prime is invariant. We can also reflect through a point instead of over a line. So this one is a reflection through the origin. So the abbreviation will still be lowercase r, but they'll use an O for origin. They might even put the ordered pair 0, 0 there. So that's how we read the shorthand notation, reflect triangle ABC through the origin. If we look at what's happening here, A has to travel to the origin. So we're going to count down 4 blocks and then to the left 1 block. In order to find A prime, we'd have to count the same pattern, down 4 blocks and left 1. And there it is. All the points are going to travel to the origin, so B is going to travel down 2, left 1, down 2, left 1, and there it is. They all have to travel to the origin and away. If we examine their ordered pairs, though, A was at 1, 4, A prime is now -1, -4. C was at 5, 2, C prime is now at -5, -2. So this one does have a specific rule. You can take any generic point P located anywhere in the coordinate plane. It will map to P prime by negating X and negating Y. But counting works just as well, and we just saw that. You're going to count kind of a slope pattern. You're going to count down and over, left and right, or count up and then go left or right, and each point will follow its own particular pattern. So we have triangle XYZ. The use of the grid is optional. We are reflecting through the origin. This rule is pretty simple by negating the X and negating the Y. So I'm going to choose to not graph this one, and I'm just going to produce my points. So we're reflecting through the origin, negate X, negate Y, and I'll do that for all 3 ordered pairs. We can also reflect through any given point. In this case, the reflection occurs through point M, which is located at 1, -1. I would encourage you again to put this point on your graph with a nice bright color, and we should label it M. And again, there will be no specific rule. We will plot our pre-image, and then each point we will count to M and then away from M with the same pattern. So there's my 3 ordered pairs for triangle ABC, and I have it graphed. And what we're going to do is have each point travel to the yellow M. So 0, 1, I can see where it's going here. And then 1, 4, and then the path of 3, 0. Now when I look at this, I see the same shape and I see the same size, but it looks like it's been turned a little bit. So I still have produced a congruent image, it's just been turned. So since there's no rule, I'm going to go ahead and extract my points right from the graph, and I'm going to put my mapping rule, reflect in point M. This will be homework number 116. There should be 4 pages. Starts with reflection over a given line or point. You might want to just make sure you have the correct pages. I know that there's been a little bit of overlap. If you would rather me send you an electronic copy every day, something new and fresh, because it's all jumbled, then you just send me an email and I will do that. If you have any questions going through this lesson or working on your homework, please make sure you get in touch with me, and then this assignment will be due tomorrow. Have a great day.